Okay, the last mathematical method, and arguably maybe the easiest if it's set up for it, is using the elimination method, sometimes called the addition method. So I may use it interchangeably. Um, so why would this be easier? So you're going to see that if a couple things you have to do first. You've got to write both equations in standard form. Okay, so standard form is ax plus by, basically the variables x and y on one side with the constant on the other. Okay, and you align the coefficients, and if you have an alignment where you have opposites coefficients, so for example, this problem has a plus 3y and a minus 3y. These are opposite numbers for that variable. And so if I was to add these equations together, then I would lose the y variable completely, which is the objective. I got to get it down to a single variable. So if I do not have opposites, then I'm just going to look at the equations, and you can read this, but I will be explaining it as we go. You can multiply an equation, both sides of an equation, by anything, as long as you do it to both sides. And so you can create opposites if they don't exist. And once you have the opposites, you're going to see this is very, very easy to complete. So let's look at an example. So here are the two equations. You can see that I, in fact, have opposite signs, same number. So if I add the equations together, which I can do that because these equations, if I have an equal sign and equal signs, then I'm adding the same thing to both sides of the equation. Okay, so when I add that, I end up with a 0 for the term that had the opposite coefficients, leaving me in this case just the x variable and 18. Well, now it's a very simple equation to solve. X is equal to 3. Once I know the value for x, I can go back up and replace x in either equation and solve for y. So I substituted it into the first equation. So 2 times 3 for x plus 3y is equal to 12. And you can see that very easily and quickly I can solve it for y. So there's my solution, 3 for x, 2 for y. And if you check your solution, you'll see both are true. So really, really easy, especially if you already have opposites. So here's another example. You can see I have opposites here with the x's. So it's set up easily, it's already in standard form to go ahead and eliminate using the addition method. So I'll go ahead and add these, and I end up with minus 2 minus 8 minus 10y is equal to 7 minus 70. So y is equal to 7. Substitute back 7 for y. I did it in the first equation. It doesn't matter which equation you do it in. And when I do that, I get down to a single variable again. Solve for x. X is equal to 4. So x is 4, y is 7. If you check it, it checks up. Perfect. Okay, I don't know if there's much value in doing another one, but again, we got opposites already in place. So when I add these, I end up with 5x is equal to negative 25. So I divide by 5. I get x is equal to a negative 5. Substitute it back into either equation. Solve for y. 5 and 3. Negative 5, excuse me. Negative 5 and 3 are the two solutions, and they check. Okay, so the only thing that makes it slightly more difficult is what happens when you don't have opposites. Well, again, you can do anything you want to an equation as long as you do it to both sides. And so if I want to eliminate, and I look at this, well, I would go for, at first blush, if I have opposite signs already, and I can multiply one of the equations by a number to get the same coefficient, then this would be the easiest. So you can see that if I multiply this number here by 3, I'm going to get a negative 9, which would make those opposites. So I'll do that, but I got to do it to the entire equation. So here I show that I'm multiplying 3, and I put the whole equation into parentheses just to kind of illustrate the distribution. So when I distribute the 3, or in other words, multiply everything by 3, I get this, and then I'll rewrite my second equation, number 2 here. And now I have opposites. So when I add it, I get 8y is equal to 8, y is equal to 1. And again, just go back into either equation, substitute 1 for y, solve for x, and there's your solution. And again, I didn't check it, but they will check. Take a look at this one. It would be easy to get a -3 here by multiplying by -3, but it's easier if you can avoid it to just multiply everything by a positive number, just to avoid making a sign mistake. So here I already got opposite signs in place. All I need is to have y have a 2. So what do? I'll multiply this first equation by 2. I distribute it through. So the first equation gets rewritten as 2x minus 2y is equal to 4. Rewrite the second equation. I now have opposites. Add 5x is 25. Solve for x, I get 7. Replace x with 7 in either equation. I did it into the first, and I get y is equal to 5. 7, 5 is the solution, and it checks. Slightly more difficult is, what if I have to multiply both equations by some number to get opposites? So here you can see that there is no one number for one equation that will set me up. So I'm going to go for the opposite signs here. I go, you know what? If I look at a 5 and a 2, I can create 10s in both positions. I can create a 10, a -10 here by multiplying that equation by 2, and I can create a +10 here by multiplying this equation by 5. So that's what I did. I multiplied everything by 2 for the first equation. I multiplied everything by 5 in the second equation, and it gave me my opposites that I'm looking for. Now when I add, I get 31x is equal to 62, so x is equal to a 2. And as always, once you solve for x or y, you can substitute it back in. I substituted it into the first equation, solved it, and I get y is equal to 3. So my solution is 2 and 3, and again, you can check it, and they will check. How do I know that I'll have infinite solutions? If I do the same process, so here I go, let me multiply this first equation by 2 so I can get that to be a -2. When I do that and I add, you can see that the x terms cancel out, the y terms cancel out, and I'm left, and the 16 and the -16 add up to 0. If I get two things that are equal to each other, then it's true, then there are infinite solutions. No solutions, by error, the same problem was written twice. So there was an 8 here. I replaced it with a 3. So it's the same idea. If I multiply that first equation by 2 and then add, I eliminate both variables, but the numbers did not eliminate. And if the numbers do not equal each other, but the variables are all gone, it's false. That means there are no solutions to this equation. Okay, so you can see, and I think you would agree, this is a very, very simple way to solve systems of equations.